All right, welcome back. It's now the second week of home learning, distance learning, and we hope that you're all doing well. We miss you so much. We are about to start what was most people's favorite unit last year, which is about the Pythagorean theorem. And before we start the Pythagorean theorem, we need to review lesson 2, which was squares and square roots, which we did way back in September. This was the notes we had. This is the notes that I had on square roots and cube roots. And so this was page 5. This is page 5 of my notebook. And if you wanted to go back and just remind yourself what the squares and perfect squares and square roots were, there you go. It's page 5 of my notebook. We're also going to review just briefly lesson 13, which is, how we solve equations, and don't call me after midnight. First we use distributive property. If we see parentheses, combine like terms, move variable, add or subtract, using properties of equality, and multiply or divide. Again, it's all about inverse operations. And we're going to need to use both of those. We'll need to use both square roots and simple solving equations in order to complete the Pythagorean theorem unit. So this page, you can see there's no essential question. It's just reviewing. What I'd like you to do right now is pause, write down these problems, and attempt them on your own. Now that you've attempted them on your own, let's go over them together. The first question we have is 10 squared. That would be 10 times 10, or 100. And in this unit, I actually encourage you to use a calculator to check your answers. This means the square root of 121, which means which number times itself is 121, and that would be 11. In a problem like this is the same thing as saying the square root of 144, which is 12, divided by the square root of 25, which is 5. And you are fine to leave it like that. If you wanted to change it to 2 2/5, you could, but I am very happy if you're leaving it like 12/5. For number 4, the negative is on the outside. We know the square root of 36 is 6, because 6 times 6 is 36, so we'll say negative 6. Here we have 3 squared is the same as 9, 7 squared is 49, and so that's that answer. When you have a square, we know it's the side length times the side length. Area is side squared. So if the area is, or the side length is 4, 4 times 4 is 16, and that's going to be a square unit. Now, the inverse of squaring is square rooting. So if we know the area is side squared, we would take the square root of both sides, and it turns out that the square root of the area is the side length. So the square root of 81 is 9. So the side length is 9. Just as a quick review of equations, we know that we have to use inverse operations. Here, don't call me after midnight, the first step is actually addition or subtraction. The inverse of adding is subtracting. I subtract 15 from both sides. I then have 3x equals negative 9. The inverse of 3 times is divide both sides by 3. I get x equals negative 3. In this problem, my first instinct would be to subtract 40, but I realize I have y's on both sides, and I need to move the variable. So I am going to subtract 9y, so we get the variable to one side. I then end up with 40 equals 4y. My final step would be the inverse of multiplying, which is dividing by 4. I end up with 10 equals y. And finally, don't call me after midnight. I see that I have parentheses, so I'm going to use distributive property. I am just going to write these down, and then I have 3 times x, which is 3x, and 3 times a negative 2, which is negative 6. I now want to combine like terms. 2x and 3x equals 5x. I then want to move the variable to one side. Even though I prefer having a positive variable, I need to move the 5x to the other side, so I subtract it. And I get 3x minus 5x is negative 2x. And I am left with negative 6. I now want to divide both sides by negative 2. I get x equals 3. One of the things you can also do on all of these is go through and check your answers.